First, quick thank you to our sponsors. This is Active Countermeasures sponsored, but, all of our sister companies, we all kind of support each other. So here they are. If you get through this and you have fun with it and you want to kind of take this to the next level, we're running a level 1 threat hunting class in July. That's the kind of intro to threat hunting class, if you will. It's about half content, half hands-on labs. That'll be running in July. And I'll have a link to that towards the end of the class. I'm also doing an advanced threat hunting class. That's funny. I say last class until fall. Well, it's going on next week. So next week, and then I don't think I do it again until like September or something like that. So if you want to jump in on that, there's a link on the bottom. And as far as slides go, they're in the Discord channel. So you can go in and grab them from ACM webcast-content. So it is the next channel down from the one where we're kind of carrying on chats. The data set that I'm going to use as I go through and kind of do these labs today is, in that link that's there. And then there's a script I'm going to go through and show you, and there's a link to the script. So you can go through, you can grab all this stuff if you want to go back and kind of walk through it and do some of this stuff yourself. But like I mentioned at the beginning of this, the original idea was, well, hey, let's talk about open source tools. And I thought about it. And I'm like, oh, we talk about open source tools all the time. Not that that's a bad thing. It's not. But we've got like really good coverage on this already. For example, that that intro level 1 threat hunting class. We have all of these tools get covered as part of that. And we even have hands-on labs for you to go through and use them. So I think we cover these a lot already. What I really wanted to kind of get into today was, how do you leverage these tools to solve problems? In other words, the tools have certain things they're kind of designed to do, but sometimes you actually want to kind of twist them a little bit to maybe accomplish something that the original authors may not have intended in order to be able to solve a problem that you have. So that's really kind of what I want to get into today, is the Cerebral tools for threat hunting. How do you go through and identify what problem am I trying to solve? Can I break that up into smaller components that doesn't seem as monumental to go through and try and solve? How can I go through and leverage and manipulate different tools to be able to go through and get the answers that I need to find? That's a lot of what I want to kind of get through today. So what I'm going to do is I'm going to talk about beacon detection using Zeek data. So we've got some Zeek data. We don't have Rita. So, yeah, we have Reader in this multiverse. Let's pretend we don't. I've just got some raw Zeek data, and I want to go through and try and figure out other beacons there that I need to worry about. But I kind of wanted to toss out what makes a beacon, because I actually see a lot of, how do I want to say it? It's not that people are wrong. There's different opinions here. Like for some folks, a beacon is only when it's going to someplace evil. For other folks, it's not. It can be going anywhere. It has to do with the signaling. And so I'd really love to kind of get a consensus on, when you hear the term beacon in the context of cyber threat hunting, what does that term mean to you? What is it that we need to be able to go in and look for? What are its attributes? What are its behaviors? Because if we can kind of wrap our brains around that, that becomes a target that we can then go after to try and see if they're running on our network. So here's what I'm going to do. Let's go through and kind of look at this live. So I've got a data set here. Let me clear that. I've got 24 hours worth of Zeek data to work with. And the files I'm going to be working with predominantly are the con.log files. So as you can see, I've got 24 hours of con.log. If you're not familiar with this output, if you take a PCAP file and you process that with Zeek, Zeek will create one of each file type that it needs to. So like con.log will have all the different connections in it. Files is, the clear text file transfers. SSL is obviously SSL or TLS traffic that it sees. X509, describes the digital certificates that it sees. So it'll just create one copy of each file and that's it. But if you have Zeek listening on the wire, what Zeek will do is every hour, it's going to go through and write out a copy of each of its log files. And then the next hour, it'll do it again and do it again. So I end up with a total of 24 files, one for each hour, throughout the course of the day. So we've got 1 day's worth of log files to work with. So let's see, learner was saying beacon continuous intermittent communications that is maintained with a set of IP addresses. Cool. A call tell the world I am ready for trouble. Okay, that wasn't it. Unless it's tunneled in DNS. Yeah, or unless there's a content delivery network sitting between you and the C2 server. That's something I kind of ran across this weekend. But the, regular signaling between two endpoints, whether that endpoint is a fully qualified domain name or an IP address, yeah, we're kind of getting into beacons. One of the things I see a lot with folks is they kind of assume beacons are a lot of traffic, right? What do I mean by that? Let's take a look at just what we have in this con.log file. So I'm going to go through it. I'm going to say cat con.star, so that way I get all the con.log files. I'm going to say I want to go through and I'm going to pipe that through Zeek cut. I think folks know where I'm going with this. And what I'm going to do is I'm going to extract out every IP pair that communicated with each other. So I'm going to say id.rig underscore h, id.resp underscore h. And for folks who aren't familiar with like the Zeek cut syntax or anything like that, this says, well, let's take a quick look at a con.log file. That would make it even easier, right? 0, 0. There we go. Let's just take a look at one con log file. So if you've never seen Zeek log files before, here's what it looks like. Here's my timestamps. These are all in epoch time. Here's a unique identifier to describe this particular session. So if I need to correlate data across multiple Zeek files, that's the unique identifier I'd use to do that. Here's where the traffic was coming from. Here was the upper port number being used, where it was going, port number being used. If I arrow to the right, I can see this is UDP53 traffic, so it looks DNS related. Here's how long it was going on for. This describes what happened in that session. SF basically described this looked like a normal connection from start to finish. I didn't see anything really odd about it. I've got, how much data was transferred back and forth. I get all sorts of little information that's in here. Now, one of the things I can do with Zeek cut is I can say, okay, I don't want to look at all of this. I only want to look at certain fields. And the way I tell it what field I want to look at is by using the field identifier. So this is how I describe a source IP address. Here's how I describe a destination IP address. So to go back to the command I ran, let's run that again. So I just said, list out the contents of all the con.log files, pipe it through Zcut, and that source and destination IP address show that. So what I can see here is I had a lot of connections taking place from this IP address to this IP address. And the first, well, it looks like it's bouncing back and forth between .2 and .3, but you can see I got a lot of them going on. Now, what if I wanted to go through and I wanted to try and add those up? In other words, I wanted to go through and see what's the raw quantity of connections that are taking place. Well, let's pull that command back up. First, I'm going to sort it because that's going to get, anytime the source IP address and the destination IP address is the same, it'll put it one line after the other. And then I'm going to pipe that through unique C. Unique says only print out one line for every connection pair you see. -C says count up how many lines there were for each pair. So that's going to give me a numeric value to tell me how many times did a connection take place. So let's run that through head to see what we got so far. And what you can see is, oh, hey, there was one connection between these two IP addresses. There was 4 between those. There's 3 between those. Well, we're looking for lots of connections to get started, right? We're looking to see, is there a lot of connections that are actually taking place? So I want to sort this data out a little bit more. I'm going to say sort a second time. And this time I'm going to say -RN, do a reverse order sort, meaning high numbers first down to low numbers. And I'm just saying -N that this is a numeric value. Don't handle it as alphanumeric characters. And now I'm just going to pipe that through head. And here are my top 10 connections. So notice here, I've got 32,831 connections that took place. Okay, that's a lot, right? Pipe all the things. Yes, you can definitely pipe all the things. That's a lot. I mean, from a beacon perspective, right? We tend to think beacons are noisy, they connect a lot. If I was going through and trying to use how many times did a connection take place, I may look at this and say, that kind of looks like it might be a beacon, right? I might want to pay attention to that. Hey, I might want to pay attention to that. I'm going to run a script that I'm not going to tell you what it is yet. We'll come back and we'll cover it in a minute. But I'm going to run these two IP addresses through this script, and then I'll describe what's the output we're looking at. So I ran it through this script, and here's what spit out. See the left-hand side here? This is the hour of the day. So what this is telling me is that in the very first hour of the day, there were 6,263 connections. In the second hour of the day, 2,987. And the third hour of the day, 6,388. You get the idea. Now notice 4, 5, 6, and 7 are missing. Notice 11 through 20 are missing here. So we're not seeing data in every single hour of the day. Also, notice when the data is reported, this data is bouncing all over the place. It's not, so Cyber 4 said, not a beacon. Yeah, why is Cyber 4 saying not a beacon? Because with a beacon, we expect some sort of regular communications that are taking place. Or in other words, I'd expect to see about the same number of connections taking place each hour, and that's not what we're seeing here. Some hours are missing entirely. Some hours, have a lot, some have a little, and it's drastically different. That's definitely not a beacon. Okay, what about the next one on the list? Let's try that. So I'm going to go through, I'm going to run beacon data against these two IP addresses. That's not a beacon either, is it? We even have fewer data points. And again, they're kind of bouncing all over. So this is busy traffic, but it's not what we would define as a beacon. One of the things I didn't see kind of identified in a beacon description is that there's some repetitiveness to it. It might get jittered. We might change the exact timing, but we expect to see, like I said, about the same number of connections taking place each hour. Okay, our second one, this has 6,000 connections taking place. So what about this one? Let's take a look at this one and see if this fits our bill. Nope, not even close. We got 2 hour points with his data. It looks like this is just a flood of traffic over a short period of time and then died. So one of the things kind of standing out to me here is we're actually kind of looking at traffic coming in from the internet to a virtual machine that we're running. So beacons tend to leave our local network and go out. So what we may want to do is go through and see, let's take a look at only the traffic that's leaving our system to go through and see, is there something in there that we need to worry about? So here's the command I'm going to run. So I'm saying cat con.star, same as I did before, Zeek cut these two IP addresses, and then I'm sorting it, unique seeing it, sort-rn, and then see this command here? This command is using awk to say if the second column, that's this column right here, has this IP address in it, go ahead and print that out. In other words, if the source IP, if this IP address is not the source IP, we're not going to see that data anymore. So to kind of contrast the two, stop doing that, Windows. Here's our first set of data. Here's our second. So notice we saw some bigger quantity of connections taking place with this one, but they were coming from the internet coming in. These are all just our internal system going out, but the connection counts are a whole lot smaller, right? Now we had connections, notice in our top 10 here, we were seeing like, let's call it 1,000 and higher. In our top 10, we had 1,000 or higher that were taking place. That's a lot. So if I was trying to use raw quantity of connections to kind of figure out who I should focus in on, I would be focusing in on these. And as we saw, they really aren't a beacon. So I'd spend a lot of time kind of wasting my time. What about these smaller level of connections? What about those? Let's go through and take a look at, let's take a look at one of these 288s just to see what's going on. That's not a lot of connections in the course of the day, especially when you compare it to what we saw in the top 10, right? What's this look like? Oh, hey, look. Here is all of my hours, and every single one of those 12 connections exactly took place. Cyber4 says beacon. Yes, I would concur. This is definitely a beacon. So it's not about the raw quantity. It's about the repeatability that we're seeing. What's kind of cool about this is this beacon jittering? Who knows? It might be jittering a couple of seconds either way, but because we're looking at it in 1 hour blocks, we're actually just normalizing that jitter out. Let's say we're beaconing once per minute and we're beaconing, plus or minus 50%, which means my dwell time can be as short as 30 seconds, as long as 90 seconds. Well, I'm going to get 30 seconds about as often as I'm going to get 90 seconds, right? They'll average each other out and come out at 60 seconds. So this is actually a great way to go in and look for beacons, especially ones that are jittering, because this just naturally normalizes out the jitter. That's kind of cool. Let's take a look at what else we got here. Let's take a much smaller one, right? Let's go look at this one. So this is only 96 connections. So that's less than 100 in a day. So I'm going to go in, I'm going to say beacon data. I'm going to look at that. Those 2 IP addresses. Oh, look at this. I've got all 24-hour data points in here. It's for just about all of them. Yeah, beacon, it's all the same thing, right? But notice sometimes I see 5. Sometimes I see 3. This tells me this is a beacon that's jittering. That's why sometimes the hours don't match up exactly, because this one might have had a couple of short delta beacons in it, and that's why it ended up signaling 5 times in that hour. This one had some long delta times in its beacon, which why it only ended up shooting out 3, but we're averaging about every 15 minutes here. By the way, does anybody recognize this? See if you recognize this. If you do, go ahead and throw it into Discord. What about this one? We're down to 38. Let's try that one. That one's interesting to me. Bacon data. Okay. I think that was a Freudian type. I saw the word bacon and just in the back of my head started saying, bacon. I haven't had bacon in a while. Do we have any bacon in the house? Maybe I can have bacon after this webcast. And it just came out typing. Okay. What about this one? Well, we had 10 in the first hour, then 2, 6, 10, 12, 6. And no, that doesn't look like a beacon to me. This one doesn't look like a beacon. But notice the difference. Before, we were just trying to look at raw quantity, and we were making an assumption. We were saying lots and lots of connections must mean it's a beacon. But when we started analyzing the timing, we saw, no, it's not really a beacon. That's not really what's going on here. When we go in and broke out the timing, that's what made it a whole lot easier to go through and figure out, right? Let's go back up to this one, because I want to carve this one up a couple of different ways. So I'm going to say beacon data, those 2 IP addresses. And hey, look, same thing we were seeing before. This looks like it's going off about 4 times every hour. Sometimes, 3, sometimes 5. Let's carve this up slightly differently. I got a different script here. What's this script telling me? This script is telling me that 24 out of the 24 hours being analyzed had data in it. My minimum value was 3. My maximum value was 5. And my standard deviation was about 0.4. Anytime you see a standard deviation of like 2 or less, you're probably looking at a beacon. Let me just give you another example of that when it's not a beacon. I'm going to go through and grab this one here, that very first one we looked at. And let's run that through this beacon sum tool. So if I run this one through it, 9 out of the 24 had data. Here's my low, here's my min, here's my max, here's my standard deviation. Remember I said 2 or less is probably a beacon? This is 2,288. It's not even close, right? Okay, cool. Is there any other way I could go through and look at this data? Yeah, I could do something like, let's say, beacon graph, those 2 IP addresses, and I'll put a scale of 10 in there. And then when I go through and run that, I get this. Here's my pretty little graph of what's taking place. Oh, look, this is pretty much flat line, right? If anybody's sat in on these before, you know I'm kind of obsessive about if you're looking at 24 hours worth of data and you're plotting out each hour and you can come pretty close to a flat line, that's a beacon. What I like about these different scripts is this gives you something visual, right? This gives you something visual to go through and analyze. It makes it really easy to see. But this gives you something visual from a command line perspective. This makes it real simple to kind of look at that and say, oh yeah, hey, I've got all of the 24 hours in there. And yeah, there's a distinctive pattern there taking place. This is kind of neat because it gives me summary information that I could then turn around and pass into other scripts. Like I could go through and process my data this way automatically, and then look at this value and say, is it less than 2? If so, this is a connection pair I may want to go in and pay attention to. Okay, so what are these scripts that I'm playing around with? They're all basically the same thing. Let's see if I can remember where I put them. User bin, there we go. Cat, user bin. Oh, spell user correctly, Chris. Okay. Here's that script that was giving me this output that we're looking at right here. Cat con.star. We talked about that before, right? It's just listing out the contents of the con.log file. Zeek cut. I've got a new entry in here that we didn't have before. Let's go in and kind of talk about what's going on there. Actually, let's do this. First, I'm going to run it without the D, and then I'm going to run it with it. So here's the problem we're trying to solve. The problem we're trying to solve is we've got Zeek data, and we want to go in and we want to look for repetitive signaling, right? We've got 24 hours worth of data, and we want to be able to go in and look to see, let's see. I was today years old when I discovered that reader is written in Go. Yes. Cool. Yeah, and I'll kind of flip back into Reader in just a little bit because we're making some changes to Reader. I'm going to come back and sync back and talk about that one in just a little bit. So again, to go back to the problem at hand, the problem at hand is we don't want to look at just raw quantity, right? We want to look at a breakdown on a per hour basis. How can we do that? Well, here's our first problem. Our first problem is how Zeek goes through and identifies time for these connections. On the upside, it's epoch time. It gives us a high level of granularity, right? You know, dot out to, what's that, 6 places. So I've got plenty of resolution to work with when going in and analyzing my connections. On the downside, it's an epoch time. We don't really work with that as humans, right? So is there a way for me to go in and manipulate that so that maybe I can look at it such that it'll make a little bit more sense to me? Well, yeah, one of the things I can do with Zeek-cut, and this is, I've noticed a lot of folks don't even know this is here. I can say Zeek-cut -D, and -D will change that timestamp to be human readable. So what's this telling me? Well, here is the day this traffic was captured. So March 1st, 2022. And then I've got, excuse me, March 14th, my bad. Here we go, March 14th, 2022. And then I have the letter T. And then after that, this is the hour, minute, second, and then here is my GMT. Now, I want to go in and break things out by hours. Well, that's kind of hard to do with epoch time, right? I'd have to go in and come up with a way to kind of like group things in groups of 3,600 because my epoch is, going once per second. So I need to group it in 3,600s, and that'd be a real pain in the butt. But hey, look here. I've got the hour right in here. So one of the things I could potentially go through and do is just say, I want to go through and I want to cut that out. Let me show you what I mean. So I'm going to say cat con dot star. That's right, because we got multiple files here. Run that through Zeek cut. I'm going to say -D because I want a normal date. I'm going to say TS for the timestamp, id.rig_h for the source IP, id.resp_h for the destination IP address. And that's going to give me this output that we see here. Now, what I'm interested in is this hour. How do I get to that? Well, I have a couple of options, actually. One of the things I could choose to do is I could use set. I could go through with set and just say, let me just copy this in because it's a little easier than typing it. I could go in and say, hey, set, anytime you see a capital T, change that to a colon. And then I can use cut to say my delimiter is a colon, and I want to go in and grab field number 2. What are you talking about, Chris? Okay, let me show you what the output looks like now. So notice before I had this letter T after the 14. Once I ran this sed command, my T got changed to a colon. Well, now that that's a colon, I can call this field 1 and this field 2. So now I can go in and just simply say, I want to use cut. I'm going to change my delimiter from being a space to being that colon value. And then I'm going to go in and say cut field 2. Run that through head. Oh, look, I've just extracted out all of my hours, and that's it. So that's one possibility for doing it. The other way I could do it, which quite honestly I think is a little bit easier, is instead of using sed, I could probably get away with just using cut, but I need to go in and I need to tell it how many bytes to offset in. So if I go in and count, how many characters do I have here? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I want to ignore the first 11 characters, and I want to grab characters 12 and 13. So I'm going to go in and I'm going to say, hey, cut. I'm not going to use fields. I want you to just cut based on bytes, and I want you to cut out bytes 12 and 13. Now let's run that through head. Oh, hey, look, that gives me the same results with a little bit less typing. That's kind of cool. So wait a minute. So what's this doing for me, Chris? Well, let's take this a little bit further out. So now I'm going to go through and I'm going to say sort. One of the interesting things with Zeek is that Zeek writes the connection after the connection closes. So if I have a connection that opens up that runs for 10 seconds, and then I have another connection open up immediately after that that only runs for 5 seconds, the 5-second connection will actually get written to the log before the 10-second one, but the 10-second time is going to start before the 5-second time does. So these timestamps on the left don't always line up exactly right. So I want to go through and leverage sort to go through and fix that. And then I'm going to pipe that through and I'm going to say unique-C. Let's see what this gives us so far. Okay, notice what this has gone through and done. This is going through and this is showing me how many connections am I seeing each hour. Now I'm looking at the raw data, right? I'm not looking at a specific connection pair. I'm looking at all the connections that are in the con.log file right now. So that's why you're seeing such high numbers. But notice what this has done. This has gone through and this has broken everything up for me. Now, one of the things I could choose to do if I wanted to is I could try and clean these up a little bit. Notice I've got a lot of white space here, right? That's just because this first value is getting offset from the side. If I wanted to clean that up, I could go in and I could say, let's see, I could use TR for that. And I could say, I want to go through and I want to collapse down anytime you see multiple instances of a space character. That's what that does there. So now if I run that, oh, hey, look, now everything is left justified. So now everything's off to the side. Now, what if I don't want to see it this way? Right? Because we're kind of looking at the hours and we're trying to see how many connections am I getting per hour? And that original output we looked at, we had the hours on the left-hand side and the quantity on the right. So how do we swap these two columns and print it that way instead? Well, we can actually go through and we can use a tool like awk for that. I can go in and I can say, so let's pipe this through another command. And I'm going to say, hey, awk, first print column 2, then print column 1. Now, when I run that, oh, hey, look, now I'm seeing number of connections per hour. The only thing missing at this point is we want to be able to go in and focus on specific connection pairs, right? This is showing me all the connections in the data. What if I only want to go in and look at specific pairs? Well, if I look at the command, I extracted out the source and destination IP address. So long as before I cut, I could actually add a grep statement to go in and look for that. What do I mean? Let me give you the, let's go back to that command again and I'll show you what I mean. So this was under user bin beacon data. But now let's go back and talk about this command. Cat con.log, we've been doing that over and over. Cut the timestamp, the source IP, the destination IP, and then print the timestamp in human readable format. I've got two grep commands here. The first one saying grep $1, the second one saying grep $2. What does that do? That says when I run this script, any variables I add at the end of the script, replace the first one here, replace the second one here. Notice, remember when I was running beacon data, I was specifying the two IP addresses I wanted to check. This is just automatically filling those in for me. And then we're cutting out the hour. We're sorting it. Unique C, we're adding them up. Here's where we're going through and we're removing that white space. Here's where we're going through and printing them the other way around. So to go back to where we kind of started in this whole thing, right? If I go back and kind of just say, okay, so let's go back to the beginning. And in the beginning, we were looking at, hey, here's our top 10 number of connections. And I was going in and saying, okay, I want to see if something is a beacon. I was running beacon data, this script, and then I was just grabbing an IP address pair, copy, paste, and now it'll fill in this IP address here, that IP address here. So it'll go through, it'll take all the data that's in the con.log files, limit it to only the data that has to do with these two specified IP addresses, and then it's going to cut out the hours and sort them so that we get nice, pretty output similar to this. Well, okay, this one isn't as dramatic. This is just saying that, okay, all of that traffic took place in 1 hour. You know, all of those connections were in that 1 hour period of time. Let me go back to one that we know there's a couple of hours in, just because that'll be a little bit more dramatic. There we go. Here's my hours. Move to the left-hand column because I was using awk for that. Here's how many connections were taking place during each hour. So again, when we were going and looking for beacons, being able to visually see not just the raw number of connections, but how many connections there were per an hour, that made it a lot easier for us to wrap our brains around, was it a beacon or not? Because when I showed you this, I'm sure most people were thinking, well, there's a lot of connections, and beacons sometimes generate a lot of connections. So this might be a beacon. I don't know for sure, but it might be. Whereas when we looked at that exact same data formatted this way instead, you could easily look at that and say, oh, no, that's not a beacon. I'm not seeing a repetitive pattern throughout the course of the day. The number of connections are changing constantly. This is definitely not a beacon. This is not something we need to go in and worry about. Okay, I ran a couple of other tools. So let me pull that beacon data tool back up again real quick. And you saw me run another tool, beacon sum. Remember, beacon sum went through and printed out how many hours had data in them, what was the smallest value, the largest value, and what was the standard deviation. How did I figure that out? Well, notice that this command, beacon sum, does everything the first one did right up to here. Up to there, they're exactly the same. The only difference, I used data mash. If you're not familiar with data mash, you definitely got to sit through our level 1 threat hunter training. Data mash is an awesome tool. It doesn't normally come with most Unix deploys. You've got to, app install data mash to get it. But this tool allows you to do some really cool things. It allows you to, what I like to use it for a lot is looking at how long were connections running for, between two systems. It makes it easy to go in and say, anytime the source IP address and the destination IP address are the same, add up all the durations of all those connections. It's great for that. In this case here, what I'm doing is I'm saying count how many data points we have. So it'll go through and count all these up, print out the minimum, print out the maximum, and then print out the standard deviation off of that data. Now notice it's saying column 1 to do that. Well, wait, isn't column 1 the time? No, it's not. Because remember in the data output before, we used awk to switch the columns. Here, we're not using awk. We're just going in and we're cutting out the field that we want to go through and use. And then we're going in and we're doing our doing our calculations based off of that. So this script, like I said, all the way up to here, pretty much the same as this script here. So I just took that and kind of built off of that. So what does that get me? Well, if beacon data gives me this type of output here, beacon summary gives me this output here. 9 out of the 24 hours had data. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep, that's right. Here's my lowest value, 554. Yep, here it is here. Here's my highest number of connections in an hour, 6,388. Yep, here it is here. And my standard deviation. My standard deviation off of the mean of this data set is 2,288. And we said anytime we see 2 or less, that's probably worth investigating as a beacon. That's definitely not a beacon. That's definitely not. All right, there was one other tool you saw me run. Let me show you that. User bin, beacon, graph. Let's look at that. Okay, up to here is exactly the same as what we had in that first script, right? This and what I have highlighted in blue is the same. The only thing I changed was I added in this command here. What's that command there? This command goes through and uses graph for X windows to go through and take that data and just create a quick little chart out of it. The $3 allows me to go through and set the scale of that as I want to. So let me show you an example of that. So I'm going to go through, let me copy that. I'm going to say beacon graph, and first I'm going to run it without specifying a third value. I'm just going to run the 2 IP addresses. And when I do that, it pops up. And here's what that looks like. So notice, not even close to a flat line, right? But let's say I wanted to set the scale. It's going to automatically print the scale based upon what's the highest value. So our highest value was just below 6,400. So it's going to give me a scale that goes up to about 6,400. If I wanted to, let's say for some reason, I wanted to scale it at 20,000 for some reason. The way I have the script written up, I could add that in as an optional third value. And now when it goes through and it generates the graph, here we go. Here's my 20,000 up here. Notice it's still nowhere close to flat, but it looks a little bit smaller because my scale's a little bit bigger. This is just a shell script. This is not, hey, I waited until someone wrote up a specific open source tool that solved my problem. This was me saying, what problem do I need to solve? I need to figure out if there's beacons on my network. What do I have to work with? I have Zeek data, and I have a bunch of different text manipulation tools. If we talk about what tools have I used here, right? So this is all Zeek. So I use Zeek. That was the data I had to start with. Here I'm using grep, the cut command, the sort command, the unique command, the truncate command, and awk. All of those are standard Linux tools. All of those are tools that you can get on any platform. Usually they're there by default. If you have some weird version that doesn't have it, you can very easily go in and install those as well. So all I did was take the data and manipulate it till I got what I wanted, a nice little pretty chart that showed me if this is actually a beacon or not. I then used that to build off of to come up with different variations of it. Like this one, like I said, this is something I could easily go in and automate into an additional script. I could easily go in and say, hey, for every connection pair, print out this information. And for any of the connection pairs where I've got, I remove the source and destination IP address, but I technically didn't have to. I could have left that in there and still continue to get this to work. It was just easier without the IP addresses in there. But I could go through and I could list this out for every connection pair, sort it based on standard deviation. And now all of my standard deviations that are 2 or less, yeah, that's something I want to go in and pay attention to. That's something that might be a beacon that I need to go in and focus on. Graph, this is for, this works over X Windows. Now notice I am on a Windows 10 system and I'm running X Windows applications. You can tunnel, so long as you have a local X Windows simulator, which Smart TTY has built into it, I can run X Windows programs from the command line off of a Linux system, regardless of whether it has X Windows running on that server or not. So that's why I'm able to, you probably notice these graphs do not look like anything you normally get in Windows. That's because this is XPlot. This is a Linux tool. But because I'm running an X Windows emulator via my SSH client, that allows me to, hey, and Bill, I think that when you were asking me like what's cool about Smart TTY, that may have been one of the ones I missed, is that you've got the built-in X Windows emulator in it so you can do cool things like this with it right across the wire, which is kind of nice.
Awesome.
Cool. So I know we've got more time, but I really want to open this up for questions and discussion because I've really kind of like jumped into the command line, thrown a lot of data at you. And I kind of want to like talk through this with folks. What questions do you have? Whether it be about the process, the tools themselves, how to go through and kind of, figure this type of stuff out. Because like I said, I could have waited until someone created this tool. I could have gone and like begged Bill Stearns, please build me this tool because you're a better programmer than I am. Instead, now anyone who is skilled with Python is probably holding their nose looking at the screen, looking at this. So if you were here for the pre-show banter, you found out I like rum. One of the things that happens sometimes when I'm solving problems like this using rum is I put weird requirements on myself like, hey, I want to use at least 10 different tools to solve this problem, right? So we've got Zeek 1, Zeek cut 2, grep 3, 4, 5, 6, 7, 8, 9. Oh, I almost made it to 10. It doesn't have to be this ugly. Like I said, if you're versed in Python, you're probably looking at this saying, "Oh, Chris, I could have done that in like half as many commands." Yeah, you could. Part of the reason I do it this way is that each tool is doing something unique, and it makes it easier for me to highlight what the different steps are. But the other part of it is I'm just not as smart with Python as some other people are. But that doesn't mean you can't jump in, hack the data, and kind of figure it out. Using rum as in drinking it. Oh, absolutely, dude. I solve a lot of problems with a nice, tasty rum beverage. My drink of choice used to be tequila, but then, the sword play would come out because it's tequila. I mean, you got to play with a sword if you're drinking tequila. So rum makes it a little bit easier to stay focused on this stuff. So Zeek gathers the logs and you can search them all in the same box. Yes, absolutely. So notice I'm just passing the output from one command to another, to another, to another. No problem. One I'm going to go through and pull out that I covered earlier, just in case you kind of lost it in the translation of all this stuff here, was paste this in. Remember, we said we were really most interested when this was the source IP address as opposed to the destination IP address. I used awk for that as well. So this was kind of cool because normally with grep is going to search the whole line of output looking for something. And so long as what you know is interesting, so long as you know what you're searching for is only going to appear once on that line, great. Grep is a great tool. The problem I ran into is sometimes this is the destination IP address. Sometimes that number is over here. And I didn't want to match it when that number was over there. So that's why I had to go to go to awk instead of grep. And with awk, I can go in and say, look for field 2. So this is field 1, this is field 2. And I'm only interested in the traffic when that field contains this value inside of it. When you see that, go ahead and print out that line. If you don't see that, skip it and go off to something else.
Chris, we've had a couple of people ask where these tools could be found. Is this something that you'd be willing to share, perhaps?
Yes, as a matter of fact.
Maybe the webcast content channel, acm-webcast-content?
Yeah, so I've got a link to download right here. But I will, no, dude, don't be. But I will happily, and I gave you some summary slides here, but I will happily post these scripts into the content channel as well.
Thank you much.
Happy to go through and do that. We got any other questions?
Yeah, Tyler Smith wrote, no question, but 2 comments. Thanks for the reminder on the usefulness of the command line when you only have that available, was one. And he suggested people in the community play around with over the wire if they want to practice similar skills. I've not used that service, so I can't really speak to it.
Yeah, I haven't either. But if it gives you a chance to go in and kind of practice this stuff, then absolutely.
We had an anonymous attendee ask, comparing bytes in and out, is the normal beacon, if there's such a thing, not always the same amount of bytes out? Is there always a difference between the number of bytes in versus the bytes out with a beacon?
So yeah, absolutely. So your bytes out are going to be one of 2 things. It's either going to be the compromised system calling out to the command and control server and saying, hey, do you have anything for me to do? I'm sitting here. I dwelled for whatever per period of time I was told to wait for. I'm now calling you to see, do you have any commands in your queue for me to execute on? It's either going to be doing that, or let's say it did that. It was told to run a command. What it's going to be sending out is it's going to actually be exfiltrating the data that was requested. So for example, let's say my compromised system calls home and says, is there any commands for me to do? And the command and control server says, yes, I want you to run PSAX. Well, here's what my PSAX output looks like on this system. That would actually now get sent out to the command and control server as part of that channel. So it's not uncommon to see a different amount of data on the down versus the up. The up is intrinsically more interesting to me because if I see the same data size over and over all day long, that tells me it's just been checking in for commands and there haven't been any commands in the queue for it. If it goes in and it checks in, or excuse me, if it, let's say it connects out to the command and control server and it sends 100 megabytes, what does that tell me? Well, that tells me something just left my system that was 100 megabytes in size. What's 100 megabytes in size? Well, hey, let me go look at my customer database. Let me look at my Excel spreadsheets. Let me look at what an attacker might be interested in on my system. Chances are one of those are going to add up to about 100 megabytes. So yes, they will be different. And to me, outbound is the most interesting of the two. Notice anything else in there, Bill, that looked interesting? So Tor said, new to this, how would I go about recreating Chris's presentation on my VM for further hands-on experience? Good one. So first, grab the slides in the resource channel. This is slide 3 or 4 or something like that. It's towards the beginning of the deck. This is the link to the Zeek logs that I used as part of the doing this. So now what you can do is you can go back, rewatch the video, and watch me do a command, pause it, go in and do the command yourself. You should get exactly the same results I do type of thing. I also put a link to be able to just quickly and easily download that script. But I also went through and threw that all the contents of all 3 scripts into the Discord resource channel. This is something I actually get into a little bit deeper. Well, actually, probably not a whole lot deeper than this, but there's more opportunities to play with it as part of the advanced threat hunting class. You know, this is one of the ways we go through and look at data to say, is this really a beacon I need to be worried about or not? Which kind of makes it handy. One thing I did want to go over. Let's see. Yeah, I wanted to look at this one. So we've got some stuff here that looks kind of beacony, right? We went in and we said, let me show you this. Beacon data between these 2 IP addresses. We said, oh, hey, look at that. Lots of stuff showing up every hour. Yeah, I've got multi in here. Let's do a Rita show beacons. And then I'm going to say grep. I should be able to get just the external IP address. So we looked at this and we said, yeah, that's definitely a beacon. Let's see what Rita thinks of it. Oh, yeah. We got to tell it what database to look at. Yeah. That's a pretty low score, isn't it? You know, here's that confirmation on 98 connections like we saw before. Yeah, Rita kind of struggled with this. We've actually just gone through testing on a number of changes to Rita's back end to take advantage of a couple of things. One is that beacons have longer deltas to them now. So for example, this one here, you can see that's going off about every 15 minutes. That's a fairly extensively long delta, and it's variable. We can see that the delta time's changing. So there's definitely a decent amount of jitter involved too. And Rita kind of struggled with these a little bit. We've gone in and made some changes to the back-end code. This is going to be coming out over the next couple of weeks. What was cool was we were able to get this up to like almost a 90.9, a much higher level of detection. And as part of doing that, things that weren't beacons now became kind of buried into the ground noise a little bit higher as well. So for example, let's look at, where to go? Oh, come on. Yeah, this one. Let's look at that one. So this is the one that, you know, had 9 hours that had data in it. The rest of them did not. And I'm going to go in and I'm going to say grep for this other IP address. And let's see what Rita thought of that. Rita gave that a perfect score. So the one with a lot of traffic that turned out not to be a beacon kind of fooled Rita. The one that turned out to be a beacon but was really low and slow kind of fooled Rita. So Rita is not hasn't been perfect. We've gone through, and like I said, we've done extensive revamping on the back end. We've got a new version coming out over the next couple of weeks that totally flips these. This score drops down to like a 0.6. It gets it down to the ground noise. This score goes up to like a 0.9. It goes up much higher. So as good as Reed has been at detecting command and control channels in the past, it's about to get even better, which I'm like super excited about. But even if you're using something like Rita, if you ever want to kind of verify the results for yourself, hey, something like this script might work out well for that. Cool. Let's see. The backend store is not changing in the next release. Yeah, not in the next release, but we're definitely looking at kind of changing up the backend, going to a different database system. There's some new features we want to pull in that's just hard with the data set that we're using today. Let's see, 2 things about Rita that I think are very cool. Rita was named after John's mom. Yeah, it was. So John's mom was named Rita, and yes, she broke into a she did some red teaming and turned out to be very, very good at it. Hey, she was a strand. I'm not surprised. Curious how much you're finding yourself spending on that per month. Oh, that's about the AWS instances. Cool. We're down to like 2 minutes. Bill, Keith, Casey, Shelby, anybody got anything else they noticed in the Discord channel that's worth answering?
A lot of very good feedback that the presentation was well received, and appreciate the idea that you can sit down at a command line and do this, as you say, without having to go and hire somebody to write a program for you. And Chris, you may kind of think I look down on it. I don't. I sit down and I do pipelines that go for 4 and 5 and 6 lines long sometimes. I have to like find my way back through them if I have to make a change. So absolutely, I use this all day long.
Yeah. Well, I am perfectly happy admitting I am far more of a hack than you are, Bill.
I'll fight you for that title.
Yes. Well, so little known secret, Bill actually has business cards for active countermeasures that has his title listed as, what was it, Bill?
I think it's master of shitty little shell scripts.
That's it.
Oh, that's right. It was something shitty little shell scripts. Yes. I couldn't remember what that first word is. So master. Yes, absolutely.
Never let your employees pick their own titles.
Yeah.
Yeah, right.
Awesome. Let's see. Is there any slide stuff I wanted to kind of wrap up with now that we're down to like a minute? We did the live demo. Yeah, I just gave you some screenshots of what we talked about. Went through this script a little bit, highlighted some stuff for you there. And yeah, hey, we're doing our next intro threat hunting class in about a month. And I'm doing an advanced threat hunting class next week. And it's the last advanced class I'm doing until probably like September. So if you want to get in soon, I would definitely try and get in for next week. And that's all I got. So yeah, thank you to everybody. Haircut fish. I'm not sure what that GIF is for, but okay. Yeah. Bill, Analog Kid is saying we totally got to make a t-shirt out of your job title.
Oh no.
I would proudly wear that.
Oh, me too. Me too.
I would proudly wear that. Regex 101. Yeah. Who is it? Is it Hal that does a Regex class?
He certainly covers it as part of some of his courses.
Yeah.
I think there might be something else on anti-siphon training on regexes.
Yep. Yeah. But that pattern matching stuff we were looking at, if you want to get into that more, yeah, this class is on that. And it's great for lots of things. I mean, here I'm using it in Zeek. You can use it in like your, I used to use it for going through firewall logs. I used to use it for firewall logs to go through and say, okay, here are all the different patterns I understand, and there's a business need behind them. Get them out of my effing firewall log, get them out of my way, because what I want to review is actually what ends up left over, the stuff I've never seen before, and going in and doing pattern matching can be great for something like that as well. You never lose from learning regex. Yeah, extreme paperclip. I would totally agree with that statement. And yep. Oh, it's Joff doing the regular expressions class. Yeah, that makes sense. Cool. Any final words for anybody? Going once, going twice.
Just that was awesome. Thank you, Chris. Yeah, great stuff.
Happy to. All right. Thank you, folks. Everybody enjoy the rest of your day. Any questions that pop up, just go ahead and throw it in this channel. I'll check back in on occasion. Everybody enjoy the rest of your day.
Awesome. And just to cover some housekeeping things real quick, because I noticed we got a few questions during the webcast. Yes, this was recorded. You can actually watch it now live on YouTube. Along with that, if you're attending through Zoom, you'll receive an email in the next few minutes containing a certificate of attendance from today. And as Chris said, hope everybody has a great rest of your day, and hopefully we'll see you in the next webcast.